we started with the problem of determining if a number is prime or not. And we came up with a naive algorithm for that. And then we made it smarter, efficient by saying, okay, we need to check, let's say, divisibility only until square root of n. And that was dramatically faster than, let's say, checking naively until n minus 1, especially as n became large. So clearly we have a algorithm here to find out if a number is prime or not. We can now say that, look, let's say I have another problem. I want to get a list of prime numbers until a given number. So for example, if I give you, let's say 20, and I say, okay, give me all the prime numbers that are, let's say, until this number, right? So that's a problem, which is a reasonable problem to have. Algorithm here could be, look, we have a smart function to check if a number is prime. I can run this for every number, and I can say if it's prime or not. If it's a prime, I add to a list, otherwise I do not add. Interesting to think about it, because this function itself is smart. However, this approach that we are saying, which is to check every number for being prime or not, is in fact a rather naive approach. So we have a smart function at hand, but using it the way we are using is actually fairly naive, as we'll see. But anyway, let's write a function to get an entire list of prime numbers. Not hard in concept. So basically, like I said, we can define a new function, say get all primes. Essentially, I just start with the list, which is empty. So this is a list. Remember, square bracket always gives you a list. And I just check in the range 2 to say n. So, because I want to get until n, so 2 to n. So which means I'll check all the way until n minus 1. If the number happens to be prime, then I go and append this to this list, and then I return this entire list primes, right? So I can go and code this up. So I just create a new code cell. Maybe I can just add a comment over here. It's good to add some comments here. So let's say this was a smart algorithm to check primality. Yeah. So this is done. All right. Next, I can say, well, get a list of primes. So I can add a text over here, say get a list of primes. And so I define a function called get all, let's say, primes until n. N is an argument here. And basically, I start with a list called primes, which is an empty list. And then I can just go and say for kk in range, for example, 2 to n. So I'm checking until n, which is 2, 3, 4, n minus 1. Because remember, range 2 n, the last value will be n minus 1. And very simple, I just go and ask myself, well, if, let's say, is prime smart, so that's already available to me. This number is a prime number. Well, if this is the case, remember that returns me a true or a false. If it's a prime number, it returns me a true. Otherwise, it gives me a false. So if this is a prime number, I can just go and say primes dot append, for example, the value kk. So this is perfectly fine. When I, let's say, return, and I can then go and say return primes. So okay, so here return say primes. So this function is going to return me a list called primes. I mean, seems quite okay. Just be careful with the indentations. Basically, the return statement has to be outside the for loop, and this is what I'm trying to do. So when I run this, no error, so I can definitely use this. So this function, as you realize, is available for me to, let's say, get all primes. I can test that here. I can just go and say, well, let's say get all primes, let's say until 20. When I run this, I expect a list of all the prime numbers until 20. That's 2, 3, 5, 7, 11, 13, 17, 19. Perfect, right? Let's try maybe until probably, let's say 50. So let's see how many primes there are. It turns out it's 2, 3, 5, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. Seems reasonable. All the primes have been captured. So this algorithm is correct. Question is it efficient? In fact, the answer is it's not, and we'll see this as we push the boundary with larger and larger n. We'll do this in the next video, but I hope you found this interesting. Do look at our website www.ybyte.in if you want to understand more about Python programming, about algorithms, and about Ybyte in general. Take care. Enjoy programming.